Alright, so this session I'm planning to look at some interesting uh, matrices we do use in terms of specifically classification here, uh, but this can be used for other purposes as well. Now, mainly when you look at this machine learning matrices, we tend to use accuracy, precision, recall, F1, and few other things. So mainly when we develop a machine learning model, we tend to work with the accuracy matrix, which is probably we discuss most of the time. uh, and we check the accuracy values, and we are trying to improve these accuracy values, whereas we can get better models, right? So but we try to dive a bit deep into this matrices and try to get a more better understanding how to use these matrices given a problem. All right. So initially we'll try to understand why these values are important, or like if somebody asks the question, uh, can we only work with accuracy, like so is it something which is important, and isn't it enough to look at accuracy? So to answer that question, if we get example, right? So if somebody set up a machine learning model which says it's having 99% accuracy, right? It's having 99% accuracy, which is really good in that sense. So what the model tries to detect is identify terrorists trying to board flights, right? So this is also not a problem right now in the world, but still this was a problem right back. So when somebody boarded the aeroplane, right? Okay, okay, and whether that particular person is a terrorist or not. So that's what we are trying to identify from this model, right? So when say 99% accuracy, now are we to decide that we can use this within our problem of or to a airport? But if you try to look at the data which is already there, right? So if you check US statistics, so they are in average, not probably this year, but before that, 800 million average passengers in US flights per year, right? So this is per year. And of course, if you look at the data of terrorists, right? So of course, there was 2001, there was a lot of terrorists on board. If you look at 2000 to 2017 statistics, only there were 19 confirmed terrorists on board aeroplane, right? So obviously, when you look at from this data, like this uh, data sets which are available, so of course there's an imbalance, as you can see. So there's imbalance of the data which is available, terrorist and non-terrorist. So obviously because of this skewness, so this imbalance data issue is a big issue, especially for classification. So we are not going to discuss it right now a lot. So it's called imbalance. If you read through articles, imbalanced data classification problem. So this is also very related to that. So there you will find that this model works 99% 999 accurate. So it sounds impressive, but the truth is they will not really use this model, right? Even though there's accuracy like this, it's a near perfect accuracy, but the accuracy itself will not give you a good overview of how good this model is. So I hope that you understood the problem, right? So that's where we have to look in for other related measures, machine learning measures of evaluation to uh, understand this particular problem of imbalanced data or imbalance classification, right? So here in this case, it's having immensely very few number of positives, so it will not come up with a really good score, right? Uh, all right, so now we try to deep dive into some of the other things that we can do, right? So let me get an example, another example where we can reiterate this. So to understand this, I'm getting this confusion matrix. So this is called the confusion matrix, which is common. And there what you have is, so assume this example, right? So in this example, this is about spam detection, email spam detection. So this is commonly called as the confusion matrix. Confusion matrix. So what you have here is 4 quadrants. So in this, you will see that. Okay, so there are emails which are predicted to be spam, and there are some emails which are not predicted to be spam, right? And here, if you look at the data, you have 50 samples of spam data, right? 50 samples of spam data, whereas 950 samples of non-spam data. So this is spam and this is not spam. So you can see there's a pure imbalance of the data which is there. So here also the accuracy will not directly give you, like in the previous case of the airline issue, terrorist issue, this will not clearly give you the right overall idea. All right, so that's where accuracy doesn't fit in. Right, so coming back to the confusion matrix, right? So you can see the predicted class is spam and non-spam, the other one, and then of course the actual classes are also there, the actual data. This is being a supervised learning problem, so you can build this very easily. So when you define something as spam, where actually it is a spam, so then we call this as a true positive. So there are 45 true positive cases, and then the other one is you define it as non-spam and actually it's non-spam, so that's a true negative case. So these two cases are quite okay because it shows your model is proper. But there are other two cases. This is the next case, which is false positive, where you detect it as spam but it's not a spam. So that's also a bad situation, but it's not really bad. But whereas probably the most critical situation would be this one, where you define it as not spam and it is a spam. Actually, it's a spam. So this is called false negatives. So please put your more concentration into false negatives. So mainly in our considerations, we look at false negatives and true positives. Because this case is not a big deal and this case also is not really big deal. So these two cases are quite important. So our next two matrices will be based on these two kind of principles, like, because true positives are the true cases, true cases which are good, and then the other case is the false negative case, where we do not identify the things that we should identify. So we define a non-spam, whereas it's a spam case. Right, so we will go back to the previous airline example again, but I want to take a simpler example initially. So now, if we are dealing with the next matrix, so we are going to use something called precision. So let me try to get this up a bit, or so. Okay, so I'll keep it here. Maybe I don't need this data. Okay, don't need this anymore. Right, so what I need is this. Okay, so now the first one which I'm going to use here is something called precision. Right? Precision. 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 Okay, so this is important matrix. Right. So what it tries to ask is what proportion of positive identification are actually correct. So we do positive identification. So let me try to bring it down. So this is the question it tries to answer. Right. Yeah. So, what proportion of positive identifications are actually correct? So this is a positive identification, right? All right, and also this is also a positive identification, right? But you detect this as spam, and this is really spam. That it's correct. So that's our positive identification. That's correct. Whereas this is also a positive identification, but it's not correct. So now we try to identify what proportion of positive identification is actually correct. So out of all this, right? Out of all this, how much is correct? So you give an indication how good our model is in terms of positive identification, not the negative identification. So for that, that will go with the next one, right? Okay. So now we try to build a equation for this. So that is important. Uh, so okay. So the equation should be, as I can remember. Yeah. So we try to build the equation. So the precision would be, so true positive, so which is this one, true positive. So that's the correct one, right? Not the false positive. But so you get the proportion, so it should be true positive plus the false positive. All right. So that is the formula for the identification of the precision. So please guys remember this is quite important. So, so you can get it from the confusion matrix. So if you try to calculate this, so it's 45 divided by 45 plus 5, which is 50. So basically 45 divided by 50 multiplied by 100. So that's basically you get your precision. So obviously this will be somewhat close, not somewhat close to, it's 95%. Also 90%, no, it's 90%. All right, 90%. And that means whenever this model predicts an email as spam, all right, email as spam, it is true for 90% of the time, right? All right. So that's you should understand. So when you detect it as spam, what proportion of positive and how it's correct, no? So basically, it is 90% of the time it's right. In our example, 50 emails were classified as spams and 45 of them were correct. So that's the reason for that. Right. So this is basically the precision. All right. So then we'll try to understand. So this is also gives a different dimension than the accuracy, right? And the next one which you want to understand is something called recall. So this looks at from a different dimension altogether. Right. So the question which it tries to answer, so now unlike in the previous case, right? So we try to get the definition or the question it tries to answer what proportion of actual positives, right? So we have taken the actual positives, right, was identified correctly. So it gives a different dimension into it. So, so what do you mean by what proportion of uh, actually actual positives were identified correctly? So, what are the actual positives? If you look at here, so actual positives would be this, no? So now try to identify what are the actual positives. So, so what proportion of actual positives would be this, no? These are the actual positives, no? These are the spams. We are identified as spams. So from this, what is the portion which is identified correctly? Obviously, it is this one, no? It is this one. Alright. So to do that, then we have to write our equation. So of course, identified correctly would be TP, true positive, and actually positive ones are the true positives and the false negatives. Alright, so that is the equation for recall. So if you calculate this now, so true positive again would be 45, and true positive plus false negative, so that can come to 45 divided by 65 and 100. So I'll use the calculator, and if I calculate this, it's 69%. Alright. So what do you mean by that, guys? So the meaning of that, out of all positive samples, so these are the positive samples, spam emails, 69 of them would be correctly classified. So as you can see, even though this has a high accuracy, but still your recall cannot be that high, or will not be that high, right? So because of the imbalance, so you have to, so this imbalance can be there. So now see, when you get different matrices, you can get a kind of different dimensions into the model, right? And so of course with the precision and the recall, there is a trade-off. So the trade-off is, if this goes high and this can go down, right? So, and also this goes high, this can go down. So improving precision would result in lower recall. So so what we can do on this, and also like try to understand, so we can push this model to do other things. So as an examples, so if we are to get a very high true positive, right? Sorry, the precision, very high precision, like close to 1, like 1%, you know, or sorry, 1, 0.9, so look at 1. So what can we do? So if we can get this number to 0, so there's no false positive, right? 0, and this is only true positive, so 50 out of 50, so then it becomes 1. So that means everybody identify, every email identify as a spam email. So then there won't be any non-spam email at all. So from there you can do that. So now you see that, you know, it's not proper to do it in that way, right? So there are other mechanisms to try out. All right, so that's basically the two matrices we can use, but remember there is a trade-off between, so you can't improve both, right? So that's the lesson for this. All right, that's a trade-off. Yeah. Okay, so now what we are going to do is, we are going to do the same with the other previous problem, right? So the previous problem was the airline issue. So now we'll try to model the same with, of course, precision and recall. So so if you first look at the recall, so recall is true positives, right? True positives, and divided by true positive plus false negative, right? So here, so you can obviously easily develop this. So so one of the things that you can do is, okay, so true positives are so basically in this example, true positives identify as terrorists, as false negatives would be individuals the model labels are that not terrorists, right? And actually were terrorists. So recall can be thought as a model of ability to find all data points of interest in the data. So whatever the data sets there, so you can get the most important ones, right? All right. So now what we're going to do, if we try to kind of look at from a very different angle, so to demonstrate that the trade-off, if we can get a graph, right? So it would be like this, right? It would look like this. So this is like when you draw precision and recall together, so we'll get a kind of demonstration like this. So you can see there is kind of a trade-off, right? So now what we're going to do, we are going to, because these two matrices are good, but still some situations these two doesn't go together. So we want to get a more of amalgamated model or metrics to find out better information. So that's where we use something called a F1 score, right? So F1 score is another measure we use in these classification models. And the F1 score is basically the a mean average, but this is more of a, rather than a normal average, it's called a harmonic average. So you use something called a harmonic average. Right? So you'll see when you write the equation. So what we do is basically we take this sort of equation. So I'll take a copy of that rather than yeah. So this would be the equation for F1. So again they use this concept of harmonic mean. So the harmonic mean is good because if you use the normal average, it can use some extreme values and it can basically make the thing a bit confusing. So, but getting extreme this harmonic mean, you can remove those extreme values. As an example, precision is 1, recall is 0. You can get an average of 0.5. Whereas F1 score would be 0. So it's not good. So it's good, right? It's good, right? So whereas the other way around also is same, right? So so that's basically what F1 score does. So right. So F1 score would also give you a quite an interesting picture into things. And then we can use another parameter which is called the ROC curve. That's also is important, ROC curve. So ROC curve stands for receiver operating characteristic curve. All right, so I'm not going to write it down here. So it's called receiving operator characteristic curve. So what we try to show is how the recall versus precision relationship changes as the vary the threshold of identifying the positive in our model. So there should be a threshold, and with the threshold, how these two changes, precision and recall changes together. So that's basically what we try to do. So to do that, of course, we have to understand two things to develop this one. That is true positive rate. So we have to identify a true positive rate and a false positive rate. Right? So if you have to calculate these two, it's quite simple. All right, so we did the true positive and false positive rate, so they're very easy to understand. Uh, so this can be again calculated from the confusion matrix. So let me get the true positive rate first. Yeah, so that's the true positive rate. Okay, so you can see, you can easily generate the true positive rate, and then you need the false positive rate. So as you can see, these things are quite easy to generate. So then to get ROC curve in this model, right? So this would be the structure of the ROC curve. Okay. So this is the threshold which matches, and if it is the ROC is on the positive side, so obviously that will be better in terms, right? And of course, thereafter, once you draw the ROC curve, if you can get this area under the ROC curve, so it's called the AOC, yeah, sorry, AUC. So if this is, of course, in between 0 and 1, if this is coming near to the 1, the classification performance would be better, right? So that's basically what you guys have to know about these matrices. So we talked about 4 things or 5 things from the start: the accuracy, precision, recall, F1, and ROC. And of course, these things can be used in harmony to come up with better results. Right. And let me take you to a bit of a practical. So hold on. A second. All right, so basically this notebook, so we have worked with the collabs. So if you go to my GitHub, you will find, I'll show you, there's a repository. Alright, so if I go, so there's one called, it's not showing here. Okay. So there's this data analysis repository, and actually I've taken this from this original author. It's been forked from the original author. So this is actually, I have to give the credit to him. So what I have done, so this is the original author, Bill Colson. All right. So, and he's saying all these interesting notebooks which you can use for everything that we learn, plotting and predictive analytics, random forest, many other things. And if you go to the, so I'll take it from, you can also fork this from my one. Okay, if you go here under precision and recall, recall precision, in this repo you will find a document and also the notebook, and also there's a data file. Okay, yeah, so you can get this notebook downloaded, and then what I did was I have basically added this to my Google Drive with the data set. Then I have opened it through Google Colabs. So make sure you have your file, also data file also loaded here. So then we can, or you can try out this experiment. So this is like a homework. You guys have to do this. So your final exam also, you'll get something from this. So make sure you do that. I'm not going to do everything. So we have all the information here listed down. So they use scikit-learn to do this. So basically positive, negative. So this is patient data set. So if you look at the data set, guys, you can, okay, you have it here. So this is basically the important information, right? Close this. All right. So as your classification predictive module, blah, 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 it has all the details. So I'm not going to read it. So basically you can read this from pandas. Right? So you can get the labels and the modules, right? And then you can carry on this. All the details are given here. So I'm not going to run this. And basically you have all the details here, the predicted one and also the actual one. So all these details are there, and also the confusion matrix is defined here. So you can see all the necessary things here. So this is the confusion matrix, right? So you can run them, all right, and there onwards you can continue. So the idea should be, so go ahead with this and you can calculate this accuracy scores, precision scores, everything. So I want to do this as a homework, and finally you can get those values, and also at the same time you'll know how to write your Python code to do this, and also you can finally get the ROC curve. So as you can see here, the ROC curve, and you can get some decisions out of it, right? Yeah, so please continue this sheet, so which can be, or this exercise, so it can be good, right, from what you have learned. All right, so that'll be it. So hope that you guys will complete this session as soon as possible. All right, thank you.